What's up guys, Onmaths here, and today we're looking at Surds. So we've got a nice Surds question from OCR, and then obviously, as we normally do, these questions will get more and more difficult. So this is a nice one because it's just basic rules of Surds, simplifying for question I, and then part II, or part 2, is going to be rationalised in the denominator, and then just simplifying, cancelling a fraction. So first of all, we've got to realise that root 50 can be written in a different way. I should point out that paper 5 on OCR is non-calculator, and all the questions today are non-calculator, and for Surds they normally are, because if you type root 50 plus root 2 into your calculator, into a modern calculator, it will do the Surds for you. So root 50, to simplify it, what we want to do is I use the word take out, it doesn't mean take away, but take out the bit of that root 50 that actually can be written as an integer rather than a square root. And to do that, what you can do is you can write all the factors of 50, so 1 and 50, 2 and 25, 5 and 10, blah, 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 blah. And find the pair with the highest square number. Now the biggest square number is that 25 there. So the pair would be 2 and 25. So 2 times 25 is 50. So you rewrite that root 50, and we're just going to focus on the root 50 for now. Rewrite it with the square number first in its own little square root, and then the non-squared number. Okay. Root 25 though we can write as 5. So it's just 5 root 2. So this becomes 5 root 2 plus root 2. And if we think of this isn't exactly the same, but if it was 5x plus x, we would write it as 6x. And so 5 root 2 plus another root 2 is 6 root 2s, or just 6 root 2. Okay, now on to the next one. So whenever you have a square root or a surd at the bottom of a fraction, chances are it will involve rationalising the denominator, which just basically means get rid of the square root from the bottom. To rationalise the denominator, in fact let's just write this out again so we've just got a bit more space. What you do is you times top and bottom by the surd at the bottom. Simple as that. Now the reason you can do this is because any number over the same number is just 1. So we're just timesing this whole thing by 1. So we're not changing the fraction. That will have 10 root 6 at the top. Now one of the rules of surds is when you times a surd by itself, you just get rid of the square root. And the reason for that is root 6 times root 6 becomes root 36, and root 36 is just 6. Bit of cancelling here, we can divide top and bottom by 2. And so we can write that as 5 root 6 over 3. Next up is our AQA question. Now this is one, there's a couple of different ways of doing it. I'm going to pick one way, but if you pick a different way and you get the right answer, obviously that's probably going to be fine. So what I'm going to do is just rationalise the denominator on both of these, just like we did in the last question. So I'm going to times this by root 5 over root 5. That gives us, what, 2 root 30 over 5. I'm going to do the same with the other one. I'm just showing this separate, just so it's nice and clear what I'm doing. Okay, we can see that the bottom, or the denominator of the second fraction is 10, but if you have a look at the first fraction, it's 5. So what I'm going to do is I'm just going to times top and bottom of this fraction by 2 to get the denominators the same. So that's going to be 4 root 30 over 10. Then I'm going to rewrite it like it is in the question. So I'm going to use my fractions though, the ones with the denominators rationalised. Okay, one of the features we know about fractions is if you add or subtract them, or in this case subtract them, and the bottoms are the same, you just subtract the tops. So it becomes 4 root 30 minus root 30. All of that over 10, and then 4 lots of root 30 take away 1 lot of root 30 is just going to be 3 lots of root 30. It always is a good idea to check that root 30 can't be simplified, but root 30, there's no square number that goes into 30, so we can't simplify that further. Last but not least, although in this case, yeah, is our Edexcel question. Now, there's loads going on in this question, and if we have a look, there's only 3 marks for this, which is kind of ridiculous because there's lots to do. So we're going to focus just on the numerator to start off with. So we've got root 18 plus root 2. And a good idea in this, if you can't simplify the fraction, so if there's not a root 18 plus root 2 at the bottom that we can cross out, which there isn't in this question, what we're going to do is we're going to expand it, because chances are that will help us later on. And sometimes I'll expand something and then look back and think, oh, actually, I probably could leave it as the factorized version. Maybe that would make it easier. But normally my instincts are to expand anything. So to do this, use FOIL, or just times each of them by each other, or use a grid. I'm going to use a grid just because it's simpler. So let's just get rid of that, equals. But use any method that you would use on expanding a quadratic. You use with this. It's a very similar process to expanding a quadratic. Obviously it's not a quadratic because there's no x's or anything. So we're going to do root 18, root 2, root 18, root 2. And this is just the same method as FOIL or double smiles and rainbows or anything. And something I should highlight is the fact that this is the same as this, which is why we use FOIL or anything else. I probably should highlight that. Okay, so root 18 times root 18 is just 18 because of what we learnt earlier. Then when you times the surd by itself, you just get rid of the square root. Root 18 times root 2 is root 36, because if you times surds, you just times the numbers together and then put it in a square root. Obviously this is going to be root 36 as well, and then root 2 times root 2 is 2. But root 36 is actually 6. The square root of 36 is 6. Add those up and you get, is it 32? And I should probably write down what I'm doing for the examiner, just in case I'm wrong, which hopefully I'm not. Okay, so that's going to be 32. So actually the top of the fraction, so we can rewrite this question as 32 over root 8 minus 2. Well, that's a nicer question. Okay, next thing is we need to rationalize the denominator, because if you look, there's no fraction in our answer here. So we definitely need to rationalize. Now this is quite difficult because what your instincts might say is that you times it by root 8 over root 8, but that's completely wrong, because that won't get rid of the root 8. So if we quickly do that, root 8 brackets root 8 minus 2, it gets rid of the first one, so it just becomes 8, but then we get a minus 2 root 8. Well, so we haven't got rid of the surd at all. So we've got to think if we know of a process of getting rid of that root 8 from the bottom, and we kind of do. Something you might remember from quadratics is this. Okay, this you end up doing plus 8 x minus 8, but notice there's no x term. It's x squared minus 64. It's called difference of two squares, and what it doesn't give you as an answer when you then expand that again, which obviously you get the same thing, is an x term. Now that's really useful because one of our issues with this question is we're ending up getting a surd, and so if we do the same thing as difference of two squares in quadratics, so that's the minus version of it. If we times it by the positive version of it, and obviously we've got to do the same to the top, otherwise we'll change the fraction, and we don't want to do that. Have a look what happens. So I'm going to do this multiplication here, just to the right here. So we're going to do root 8 minus 2 times root 8 plus 2. Again, you can use FOIL or whatever method you're happy with. I find the grids just easier to show. I'm not saying they're better. So we go root 8 minus root 2, root 8 plus root 2. So root 8 times root 8 is 8. 2 times root 8 is 2 root 8. Minus 2 times root 8 is minus 2 root 8. And then 2 times minus 2 is minus 4. But notice what happens here. We've got 2 root 8 and we're taking away the 2 root 8. It gets rid of it, just like it did with the x's. It got rid of the x term. This gets rid of that surd term. And so all we end up with is 8 plus minus 4, or 8 minus 4, which is 4. So that only gives us a 4 at the bottom. At the top, we can just leave that as 32 brackets root 8 plus 2 for now. Because what we can do is we can cancel again. So we can divide top and bottom by 4, and you get 8 over 1. And so our answer is 8 brackets root 8 plus 2. Now, just like I did with the last question, it says that it wants it as a b plus root 2. Well, we haven't got that in our answer. And just like I did with the last question, you need to check this surd here. Okay, is that a surd? Well, it's not a surd because you can write it with a smaller number as the square root. So if you do as we did before, factors of 8, obviously 1 and 8, we'll never pick 1 and 8, but 2 and 4, 4 is a square number. Okay, so we can write that as, so root 8, we can write as always square number first, root 4, root 2, and root 4 is 2. So let's keep going with this. 8 bracket 2 root 2 plus 2. Now I can then factorize the bracket further by dividing everything inside the bracket by 2, and I can multiply the outside the bracket by 2. I'm going to expand it first just to show this easier, but if you can do this in one step, that's fine. So I'm just going to quickly expand the bracket, and then you can easily see that 16 is the factor of both of those. But it wants it with the integer first inside the bracket. So my final answer would be 16 brackets 1 plus root 2. And let's just check that. Yeah, so A is 16 and B is 1. So Edexcel definitely were making you work for the 3 marks for that question, because there was lots and lots of stuff that you needed to do. And I like this question because it shows so many different parts of surd in one question. So it's a really, really good one to practice. Well, I hope you enjoyed that video. If you did, please click like. Please keep your comments coming in. Summer school will be finishing soon for higher tier. It's already finished for foundation tier. So click subscribe, make sure you're up to date with all the videos we release. We release them every single weekday at 9 o'clock in the morning. And if you haven't already, which I'm sure you have, check out our website onmaths.com, which is packed full of completely free maths resources to help you out. Otherwise, thank you very much, and I'll see you tomorrow.